Is this discovery wrong, or is it truly one of the biggest breakthroughs in our understanding of the universe? The James Webb Space Telescope, JWST, humanity's most advanced tool for observing the cosmos, has been unlocking some of the universe's deepest, most breathtaking secrets. However, one of its most recent findings has left even the most seasoned astronomers scratching their heads in confusion and awe. To make matters even more intriguing, a Nobel Prize-winning scientist has stepped forward with a chilling warning: what if this discovery is more than just a new chapter in cosmology, but a harbinger of a reality we're not ready to face? What exactly has the James Webb Space Telescope found out there, far beyond the reaches of our galaxy? And could the answers to these cosmic mysteries be far scarier than we could have ever imagined? The vastness of the universe and our place in it. When we think about the universe, it's easy to picture it as a vast, boundless expanse, an infinite arena filled with stars, galaxies, and countless celestial phenomena, many of which we can barely begin to comprehend. The universe, in scientific terms, is defined as the totality of everything that exists, encompassing all matter, energy, and the physical laws that govern them. But while this description sounds straightforward, it barely scratches the surface. Every new discovery seems to unravel deeper complexities, expanding our understanding in ways that continue to astonish scientists. For most of human history, our understanding of the cosmos was limited to what our naked eyes could see in the night sky. Our place in the vastness of space seemed small and confined to Earth, our home. However, thanks to monumental scientific and technological advancements, we now have tools, telescopes, satellites, and other instruments that allow us to peer deeper into the cosmos than we ever thought possible. From the Earth to the stars, we've come a long way since our ancestors first looked up at the stars in wonder. Today, we know that Earth orbits a star, the Sun, which resides in the Milky Way, a spiral galaxy among the countless others scattered throughout the cosmos. And while it's difficult to imagine, our galaxy alone contains billions of stars, with countless more scattered throughout the universe. And yet, even describing these numbers as countless seems to fall short of capturing the true enormity of the cosmos. The observable universe, which is the part we can see using our telescopes and instruments, spans a staggering 92 billion light-years across. That's right, 92 billion light-years. But this is only the portion we can observe. Beyond that, the universe likely extends even further. Its far reach is a complete mystery to us. And what's even more mind-boggling, is that the universe, though incredibly vast, is still finite in its observable boundaries due to the finite speed of light. Time travel through space. One of the most fascinating aspects of studying the universe is the concept that looking at distant objects is akin to peering back in time. This might sound like science fiction, but it's true, because light takes time to travel. The farther we look, the further back in time we are essentially observing. If you observe a galaxy that's 10 billion light-years away, you're seeing it as it was 10 billion years ago, a snapshot of the past, frozen in time. This time travel aspect is a crucial tool in understanding the evolution of the universe, the birth of stars, and the formation of galaxies. By observing galaxies at various distances, some very far away, astronomers are able to piece together a timeline of cosmic events. These observations have given scientists an approximate picture of how the universe evolved after the Big Bang. The Big Bang Theory and the evolving timeline. The Big Bang Theory, a cornerstone of modern cosmology, provides a framework for understanding the origins of the universe. According to this theory, the universe began approximately 13.8 billion years ago from a singular, hot, dense point. As the universe expanded, matter and radiation spread outward, cooling as they did. Eventually, particles began to form atoms, and gravity began to pull these atoms together to form the stars and galaxies we see today. But here's the twist: emerging observations from cutting-edge telescopes, like the James Webb Space Telescope, sometimes seem to challenge the predictions of these models. Something as fundamental as the age of the universe itself is now in question. Data from JWST has revealed galaxies that appear far more developed than we would expect for their cosmic age, raising serious questions about the timeline and formation of these galaxies. If these galaxies existed earlier than our current models predict, could it mean that our understanding of the early universe, of the Big Bang itself, needs a serious overhaul? James Webb's game-changing revelations. This is where the James Webb Space Telescope has truly come into play. With its massive segmented mirror and advanced infrared sensors, JWST is capable of detecting the faintest signals from the early universe, light from galaxies that formed just a few 100 million years after the Big Bang. This is a time in cosmic history that was previously only faintly visible, and the discoveries Webb has made are revolutionary. JWST's unique position at the second Lagrange point, L2, far from Earth's atmosphere, allows it to capture incredibly clear and detailed images, free from the distortions caused by our planet's air. One of JWST's most famous early releases was its Deep Field image, a breathtaking snapshot that revealed thousands of galaxies, many of which appeared warped and stretched by the effect of gravitational lensing. Some of these galaxies are so far away that they seem to date back to the very early stages of the universe, possibly even to the very first billion years. This unprecedented view challenges our understanding of galaxy formation. Galaxies that defy expectations. What has truly puzzled scientists, however, is the discovery of galaxies that are far larger, more developed, and more mature than we ever thought possible so early in the universe's history. Some of these galaxies appear to have formed stars at rates that should be impossible in such a short window of time. What could be causing this rapid and unexpected star formation? JWST's observations suggest that galaxies are forming in ways that don't fit neatly into our current understanding. If JWST continues to spot these overachieving galaxies, it could force a complete revision of our star formation models. What's at stake? These findings are not just intriguing, they have the potential to shake the very foundations of our cosmological models. If galaxies formed much more quickly than predicted, it could mean that the standard Big Bang timeline is incomplete, or that some previously unknown cosmic processes were at play. Furthermore, the role of dark matter and dark energy, the invisible forces that shape the universe, could be questioned as well. If galaxies are forming differently than expected, it raises the question, was dark matter behaving differently in the early universe than it does now? Dark matter, which makes up most of the universe's mass, is thought to help galaxies maintain their structure. Meanwhile, dark energy, a mysterious force that accelerates the universe's expansion, plays a major role in shaping the cosmos on the largest scales. Could the accelerated formation of galaxies be related to these mysterious forces? Are dark matter and dark energy more complex than we thought? The Hubble tension, a new cosmic conundrum adding to the intrigue, is the so-called Hubble tension. This refers to the growing discrepancy between two different methods of measuring the rate at which the universe is expanding. Some measurements, such as those made using nearby supernovae, indicate a faster rate of expansion, while measurements from the cosmic microwave background, CMB, suggest a slower rate. This tension between different methods of measuring the universe's expansion has become one of the most significant mysteries in modern cosmology. Some astronomers believe that JWST's findings could offer a clue about this discrepancy. If galaxies formed more quickly than expected, it could shift the parameters used to measure cosmic distances and the expansion rate of the universe. These connections between early galaxy formation and the Hubble tension are still speculative, but the possibility of them being linked adds an extra layer of excitement to JWST's findings. New theories, new horizons. As scientists continue to sift through JWST's data, one thing is certain: The discoveries from this incredible telescope will change the way we view the cosmos. Whether they lead to entirely new theories about dark matter, dark energy, or the fundamental nature of the universe itself, or if they force us